Alright, so let's look at an example where the right-hand side is just some linear combination of different exponential functions. These are, in a sense, the easiest of these problems because derivatives of exponential functions are the same exponential functions, just maybe times some constant by the chain rule. So we have our second order equation. Our phi of x is e to the minus x minus e to the 2x. So that's a linear combination of two functions that are linearly independent, e to the minus x and e to the 2x. So in this case, unlike the polynomial case, it's pretty clear what the linear combination that we need to use is. So our phi of x is just 1 times e to the negative x plus a negative 1 times e to the 2x. So because it's a combination of exponential functions, then all we have to do is choose our particular solution to have the same format. It's going to be some constant times e to the negative x plus another constant times e to the 2x. Now if we plug this expression into our left-hand side of our equation for y, we have to take two derivatives and then add to that 4 times the functions we see. Well, let's look at each term by term. This is the nice thing about linearity. And look at each term separately. The second derivative of this is the same thing as we see. It's a times e to the minus x. And then 4 times this is just 4a e to the minus x. So adding those two together gives us our 5a e to the minus x. And then the second term, the second derivative is going to be 4 times b times e to the 2x, because each time we differentiate, the chain rule gives us a factor of 2. And then we add to that 4 more of these, so that's 8b. So we have 8b e to the 2x. So again, phi and L of yp, because of how we chose y sub p, are both linear combinations of the same two functions, so we just set them equal to each other. And the only way two such functions can be equal is if their coefficients of the same functions are equal. That's what linear independence is telling us. So in particular, 5a has to be 1, and 8b has to be negative 1. And that's simple enough. It tells us that a is 1/5 and b is negative 1/8. So that's our solution, our particular solution. Y sub p is going to be 1/5 e to the minus x minus 1/8 e to the 2x. Now keep in mind, in reality, there's lots of particular solutions to this. This method is just helping us find one of them, because that's all we need to find is just one of them. Because once we find this, we then want to solve the equation in general, we have to add to this y sub p the solution to the homogeneous part of the problem, so that we can get an actual general solution. So this is not a general solution, this is just one particular solution.